So, hello everyone. Previously, we discussed about the linear search and binary search algorithm. So, today, let's try to understand the Sieve of Eratosthenes implementation or the algorithm, right? So, the approach of Sieve of Eratosthenes is to find all the prime numbers up to a given number n. I'll just write Sieve of Eratosthenes, SOE. So, the main approach is to find all the prime numbers up to the given number n. To find here to find all prime numbers, right? So I'll just give here prime numbers up to n. So we have to find all the prime numbers within n. Then this approach will be handy. So what we will be doing here, we will iterate marking the multiples of each prime number starting from 2 as non-prime. So again I am telling, we will iterate. So this is second step. We will iterate marking the multiples of each prime number, nothing but here. Multiples of each prime number starting from 2 as non-prime. We will be ignoring 0 and 1. We will start with 2. We will iterate the multiples of each prime number starting from 2 as non-prime. So this is the basic idea of this one, Sieve of Eratosthenes. So let's implement the same thing in the code, and also let's try to understand with the example, and later let's discuss the time complexity and the space complexity of the algorithm. Let me delete this one. So yeah, initially what I'll do, let me write the function Sieve of Eratosthenes. I'll just consider the parameter n. So first step is we will initialize the array to keep track of the prime numbers. Let's initialize the array. This is simple. I'll just give prime. Let's initialize the array. Let me give new array of size n plus 1, and let me fill this one with 0 or boolean value true. Sorry, we are filling this one with the we are initializing the array of size n plus 1, and we are filling this one with the boolean value true. So next step is we will mark 0 and 1 as non-prime, nothing but false. We are ignoring this one basically. So what we will do, we will mark 0 and 1 as non-prime, nothing but false. I can just we have already declared primes of 0, this one, equals primes of 1, this one. Let's set this one to boolean value false. So I hope this is clear. Next, let's move to the next step. We will start from the prime number 2. So as we had discussed in the approach, so I said we will be iterating the multiples of each prime number starting from 2 as non-prime, right? So let's start from the first prime number, that is 2. So let's start the iteration. This will be for let I equals 2, I into I, this one less than or equal to n. Let's increment the I. Here after this, next let's move to the next step. We will check if the current number is still marked as prime or not. So this is simple. Here current number is nothing but primes I have given. So yeah, primes, iterated value of the primes, nothing but here we are checking if the current number is still marked as prime or not. So for that, again within the if condition, let's make use of the for loop. I'll just give here j equals I into I, j less than or equal to n. Let's finally j equals j plus I. So here in this step, we are just marking the multiples of I as non-prime. So in this one approach, we had discussed the same thing, right? We will mark the multiples of I as non-prime after checking if the current number is still marked as prime, we will be marking the multiples of I as non-prime. Then finally what we'll do, we'll update the array to indicate the non-prime status. We'll just set the primes of j equals false in simple terms. So I'll just give here primes of j. This one we will be setting this one to false. So I hope this is clear. So final step is we have to prepare to collect all the prime numbers, right? So I'll just give here initially we need this one in the array output. So I'll just consider the result and initialize to the this one empty array. Then we will iterate through the array to gather the prime numbers. So we will be starting from 2, right? So this one I equals to I less than or equal to n. Let's increment the I. So finally, if the number is still marked as prime, we will add it to the result array. For adding, I'll just make use of the push. So I can simply call here if this is condition, right? Iterated value of the primes, nothing but primes of I. Then we will be we have to add the this one. We have to add the number to the result array. So nothing but result for adding. I'll just make use of the sorry. Just give me a second. Yeah, push of I. So finally, the final step is we have to return the list of prime numbers. Nothing but we have to display all the prime numbers, right? For that reason, let me make use of return primes. So sorry, we are making use of the result, right? So yeah, I'll just give here result. So finally, this is the algorithm. So this is the code, and so let's see this one whether this works or not by considering the example. So I'll just consider here. Let me give n equals 30. Let me give. We have considered. Let me consider this one. Prime numbers. So we need all the prime numbers within certain range, right? So that is n. Let me call here the Sieve of Eratosthenes function of n. Finally, we have to display that one. For that, I'll just make use of the console log here. And let me make use of string interpolation. This one, prime numbers up to. So this one will be n, and also your prime numbers. So I hope this is clear. So we are outputting the result using the console log, right? So we have to get all the prime numbers within 30. Let's run this one. I hope this works. Prime numbers up to 30. Here we got 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. So these are the prime numbers. So this works absolutely correct. So the code works absolutely correct, right? So next, let's discuss the time complexity and the space complexity. So what will be the time complexity? Here the time complexity will be big O of n double log n. Nothing but here I'll just give here time complexity would be big O of n double log n. Why it will be n double log n here? Because the algorithm efficiently marks the non-prime numbers, right? So it will be n double log n, and the space complexity here would be big O of n. Why it is big O of n? Because we are making use of the Boolean array of size n plus 1. Here we can clearly see where is this one here. Yeah, the size Boolean array n plus 1. Nothing but Boolean array. We are filling this one with a true, right? So we are making use of the Boolean array of size n plus 1 to keep track of the prime numbers. So this will be, the space complexity would be big O of n. So I hope this is clear. So this is it. Thanks for watching, guys.